Welcome back. Previously we were discussing about probable error and its theoretical aspect. Let us discuss the case that comes under the same category. Next case. The following table gives the results of the SSLC examinations. Age-wise classification is given as well as a percentage of failure. So the first line represents the age of the students. It varies from 13 to 21, and second line depends the percentage of failure, and you are required to calculate the coefficient of correlation and estimate P. P means probable error and independent result. In some question it may ask to find independent result or evaluate your result. Anyway, in this case you are asked to study the relationship between age and percentage of failure, and in this question you are asked to calculate R as well as probable error. In simple words, it means whether the age and the percentage of failure, whether it is correlated or not. That is the simple meaning of the question. Whether there is a relationship between age and failure. If there is change in the age leads to any change in failure, you are asked to find whether there is relation or not. And here calculate R and estimate P. Sometimes in the question they may ask to find P. In that case, even it is not asked to find the coefficient of correlation, first you need to find coefficient of correlation, because in order to find P you need R. So all these are interrelated. So let us go to the application part. First of all, let us try to find R. Before finding R, you need to convert the details given in the question to a table. So let us do the same question by using the shortcut method of assumed mean case. For taking the deviation, we will be taking 17 from this case and 43 from this case. So let us transfer the details of age and failure to X and Y as two columns, and next one you need to find dx and dy. For the time being we are taking 17 and 43 as the assumed means, and previously I have explained about how to find assumed mean as well as actual mean with a simple trick. Just find the mean of the X and Y. If you are using that value, that means that mean value, and if you are using that mean value for finding out the deviations, it is an actual mean method. If you are using any number that is just preceding or succeeding the mean value, then it will be a case of assumed mean. That will be the easiest method for using or finding the assumed mean as well as actual mean case. You can follow any method as per your discretion. Okay, let's come back. Here we are assuming 17 and 43. You may think that 17 is there in the series and 43 is also there in the series, whether it is an actual mean case or no. If you take the mean of X, if you are getting the value 17, then that case will be an actual mean case. Likewise for Y also like that. So for the time being we are assuming 17 as assumed mean for X and 43 as assumed mean for Y. So on the basis of this, dx will be like this. I hope you know how to find dx and take the total of dx. Once you take the total of dx, next you need to find dy. Once you found dx and dy, next you need to find dx dy. I hope you all know what all columns has to be prepared for finding out the correlation coefficient. Once you found the dx dy, next you need to find dx square. Just take the square of dx column, and finally dy square as the square of dy the column. Okay, remember in the exam don't go for any shortcut methods. don't think that dx square is just the square of dx, so we can take the total value and take the square, then you will get the total of dx. So no, never do like that. You need to individually take the squares of dx. Likewise, so dy also like that. Okay, once you found the corresponding columns of the same case, substitute the details in the equation, and the equation is like this: r equal to corresponding equation. Just go through the equation and familiarize the equation. Substitute the values in the equation here, and 9 items. 9 into dx dy is 99 minus sigma dx is dx total 0 into minus sigma dy means dy total minus 3 divided by root of n. 9 into sigma dx square is 60 minus dx the whole square that is 0 raised to square into root of 9 into dy square is 349 minus dy the whole square is minus 3 the whole square. Remember, dx square and dx the whole square, these two are different, and substitute it accordingly. Once you substitute the values in the equation by using the basic mathematical steps, you will get the value of r 0.6852. So once you found the value of r, you can interpret the details. In the question you are asked to find whether there exists any relationship between failure and age. So here you got plus 0.6852. So plus 0.6852 means you have to interpret it accordingly. There is a positive correlation. So once you found r, you need to find p. Because in the question you are asked to find p, r as well as p. So next year let us find p. Here p, the equation of p is 0.6745 into 1 minus r square by root of n. So just substitute the value of r and n only. So p equal to 0.6745 minus r square means 0.6852 square divided by n means 9 root of n. By solving that, you will get p equal to 0.1193. And remember the interpretation you have to make. For r also there is a certain pattern of interpretation, and for probable error also there is a certain pattern of interpretation. Just go through the interpretations very carefully and use it accordingly. So let us interpret on the details we have found out. Here p is less and correlation is more than 6 times the p. There is an interpretation related to probable error. If r is 6 times the p, then the correlation is significant. When the correlation is significant means there exists relation. That is the meaning. So therefore we can assert that failure is correlated with age. So this is how you need to make the interpretation and solve the case. So just go through the question, read the question very wisely. So let us go to the next part. Rank correlation. And remember, regarding the previous case, in this case you are asked to find r as well as p, and sometimes you may be asked to find p, and at the same time remember, sometimes they may ask a short type question where the value of r will be given, n will be given, you are asked to find p. Sometimes p value will be given, you may have to find r or n. That depends upon the nature of the question. So you have to go through the question very wisely and use it accordingly. It doesn't mean that you always have to prepare a table like this and to go for all these steps and interpretation like this. It may be the other way around. So you have to be very careful while dealing with the questions related to this part. Okay, let us go to the next area. Rank correlation. Carl-Pearson's coefficient is applicable when variables are measured in quantitative form, and you all know what is meant by quantitative forms. But in many cases measurement is not possible because they are in quantitative form. For example, we cannot measure the beauty or intelligence quantitatively, but it may be possible in their case to rank the individuals in some order. The correlation coefficient obtained from the rank so obtained is called rank correlation. So it's also a part of the correlation computation. The only difference is that until now you have been studying to find the relationship between quantitative figures or quantitative facts and figures, just like age, number, marks, students, likewise. But rank correlation is applicable whenever you are asked to find correlation or relationship between qualitative factors like beauty, intelligence, IQ, efficiency, effectiveness, likewise. That depends. I hope you understand the concept. So for studying qualitative details, we are using rank correlation, because for studying qualitative factors, there is no material facts or figures for studying. So you need to rank the details accordingly. So since it is based on the rank, and on the basis of those ranks, the correlation is computed. It is known as rank correlation. Therefore, rank correlation is correlated obtained from ranks instead of their quantitative measurement. Thus, when the values of two variables are expressed in ranks and therefrom correlation is obtained, that correlation is known as rank correlation. Spearman was the person who introduced the concept of Karl Pearson. Even though Karl Pearson was the father of or creation of rank correlation concept, the rank correlation idea was brought forward by Spearman. And thus Spearman has devised a formula known as Spearman's rank correlation coefficient to find the correlation coefficient from the ranks. According to Spearman's method, the formula for rank correlation is rank correlation equal to 1 minus 6 sigma d square divided by n3 minus n. If you go through the text or Google, you can see that the equation may have a different style. In some cases or in some situation, they might use 1 minus 6 sigma d square divided by n into n2 minus 1. That's another form of writing this denominator pattern n3 minus n. You can follow any pattern. We will be using this type of equation. So let's go through the application case. So remember, earlier we have been learning the correlation concept that was introduced by Karl Pearson. Rank correlation is a pattern introduced by Spearman. So remember the persons who have introduced the concept. Next one. In the equation you can see that 1 minus 6. These 1 and 6 doesn't have affect our computation, but sigma d square. So what is meant by d? D means difference between ranks. Difference between ranks means you may be asked to find the study relationship between two set of details, and since it is a qualitative factor, it will be ranked. It will be arranged according to the ranks. So you need to take the difference of the ranks. That is known as d. We will come to the application level, then you will understand the concept of d. And next one, n. N means number of items, and you all are familiar about that. And in some situation we use the sign p for representing rank correlation in some situations. So, and the interpretation is, if you get a positive one or positive rank, positive value, that means ranks are in the same direction. Same direction means they are moving accordingly, or they are correlated likewise. And if it is a negative value, it means both the ranks under study are moving in different direction. That is the concept of the interpretation. So remember these factors, familiarize the equation. Let us deal with an case, then you will get the clear picture regarding rank correlation. A case: 10 competitors in a beauty contest are ranked by 3 judges in the following order. The rank given by the first judge, rank given by the second judge and the rank given by the third judge. Use rank correlation to discuss which pair of judges have the nearest approach. So there was a beauty competition and there was 3 judges, and naturally you can see that the ranks of the judges will be different. Even though there is a criteria for ranking, there will be a difference in the ranks of the 3 judges. It is quite natural, but still we are asked to find whether there is any close relation. That is, you are asked to find whether the ranks given by the judges or any of the pair of judges have the nearest approach. Nearest approach means whether their ranks are closely related. So first of all, since here there you are given 3 cases. Remember, in correlation cases you will be studying a relationship between 2 set of details at a time. Since here 3 details are given, remember we will be selecting any 2 groups at first. Then we will be comparing another 2 items, and finally we will be comparing next 2 items. That is the concept of dealing with correlation aspect. Even if it is a case of the previous questions also, if you are getting 3 sets of data, you have to do it accordingly. So for the time being, we will be first using the first 2 judges. So here already ranks is given. So how you are going to find it? In the question it is already said that 10 competitors, beauty contests are ranked by the judge. Here already rank is given. Sometimes in the question ranks may not be given. So how you are going to find whether the given details is a rank or not? Remember, usually ranks will be beginning with 1 and it will end by maximum of 10. See, just like a case like this. In a question, how you are going to find whether it is not a rank means the values will be more than 10. It will be 50 or 60 or 70, 90 likewise. You are not going to give a 90th rank for something else. So since here ranks is directly given, it is not issue, but when some cases ranks are not directly given, you need to find the rank. We will be discussing that part in the next case. For time being, let us go through this one. So first judge and second judge is written, and we have just copied the details accordingly in the table. Next one, in the as per the equation, you need to find D. D means difference between first and second column. And remember, just take the difference between the first and second column. Don't worry about the signs. Just find the difference. 1 and 3, there is a difference of 2. 6 and 5, there is a difference of 1. 5 and 8, difference of 3. So don't worry about the sign. Just find out the difference. Once you found the D, next you need to find D square, because in the equation it is D square we have to use. So D square is easy. Just take the square of each individual item in D and take the total of D square. Next, you need to substitute these details in the equation. Rank correlation of first and second judges. So because we have selected first and second judge, equation is 1 minus 6 sigma d square by n3 minus n equal to 1 minus 6 into sigma d square 200 divided by n3. N means number of items. 10 raised to 3 minus 10, you will get minus 0.21. Okay, you have found the correlation of those 2 judges. 1 and second judge is computer. Next one, let us find the relation between first judge and third judge. Similarly, we will be plotting the details of first judge in the column and third judge in the corresponding column. Next, you need to find D. D is very easy. Just take the difference between. So D is the difference between the first judge and third judge. Just take the difference between these 2 columns, first judge and third judge, then you will get D. And once you found D, next you need to find D square, take the total, and let us use the equation rank correlation of first and third judge. We were studying first and third judge. Equation is the same one. 1 minus 6 into sigma d square, here it is 60, divided by 10 raised to 3 minus 10, you will get 0.636. It's a positive value. Here it was negative. So the remaining next 2 is studying relationship. Here see 1 and 2 is study, 1 and 3 is study. Next you need to study only 2 and 3. So we will be taking the second judge and the third judge. Second judge is written accordingly in the corresponding column. Third judge also written. D. I hope you know understand how to find D. Once you found D, next you need to find D square. Take the total. Again substitute the same in the equation. You will get 1 minus 6 into total 214 divided by denominator same value equal to minus 0.30. So we have computed the relationship between each of the judges. Next you need to find or you need to interpret the results. So you can see that in the case of first and second judge you got minus 0.21. In the case of first and third judge you got plus 636. Finally second and third judge you got minus 0.3. So naturally we can say that the first and the third judge is having the nearest approach. So once you found the values you need to interpret it accordingly. The rank correlation coefficient in the case of first and third judges is greater than the other two pairs. Yes, if it's evidently clear. In both other two cases you will be getting negative and smaller relationship value, but in case of first and third judge you are getting a positive 0.636, fairly good. Therefore first and third judge have the highest similarity of the thought and have the nearest approach to common taste in beauty. So this is how you have to find the rank correlation. Remember, it is a special case where you are given 3 set of details. You will be given only 2 set of details. Whenever there is 3 set of details, you have to do it accordingly. Even if this case, similar type of case is coming under the correlation, Carl Pearson situation also, you have to do it like this. Study relationship between two set of details, then again another 2 set of details, and accordingly. So this is how you have to deal with rank correlation, and also whenever there are more than 2 set of details you have to study like this. See, take 2 items at a time and study until you cover all the relationship between each of the individual items. So this is how you have to deal with the rank correlation situation. So just go through all these concepts. Next time we will be dealing with a situation where it's the similar case, rank correlation will be discussing, where you will be given the value of rank correlation value will be given, like just like this value will be given, and d square might be given. You need to find n. Sometimes n may be given, d square has to be found. So depending upon the details you have to find the necessary value accordingly. We will be discussing that part in the next slide. Just go through it and we will discuss further in the next session.